Hey, Danny, have you ever wondered if there's a better way to heal rotator cuff repairs?
Like every single day.
Well, get ready to rethink everything you know, thanks to Atrion Orthopedics. Imagine a world where tendon to bone healing is faster, stronger, and more reliable. Sounds like science fiction, right, Danny?
Yeah, that's not real. Don't lie to our listeners.
But it's not. Atrion Orthopedics is pioneering this revolution with this cutting edge synthetic nanofiber scaffold. Curious how it works, Danny?
What is it? Just like a regular patch, right?
Picture this: a bioabsorbable wick called rhodium. It's placed right where the healing happens, between the tendon and bone, mimicking the body's natural extracellular matrix and optimizing an autobiologic healing environment. Cool, huh?
I mean, yeah, it's much better than scar tissue.
But wait, it gets better. This
No.
tiny marble is not only designed to promote Sharpie fibers restoration and tissue remodeling, but also boost and supercharge strength and function in rotator cuff repairs.
Game changer.
Surgeons love it, patients adore it, and ASC administrators can't get enough of it. Why, Danny?
Is it cheap?
Because Rhodium's straightforward implementation procedure means you can stick with your preferred repair technique. Plus, it's adaptable for both ASC and hospital settings, and it's cost effective. So the suits
That's
like it
it.
too.
Cost
And
effective.
with almost 10,000 successful cases completed and published clinical studies, what's not to love, Danny?
Kind of love it already.
So, are you ready to join the tendon to bone healing revolution with Danny? Visit atrionortho.com. That's atrionortho.com. ATREONORTHO.com. And discover how Rhodium is reshaping the paradigm of rotator cuff augmentation. Atrion Orthopedics, where the healing meets innovation.
Girl, to get a lot of dough, anything is possible. Turn me up in the headphone. Yeah. Grind to get a lot of dough and dirt through all the obstacles, cause anything is possible. Yeah. Oh man, I got a lot of goals. Stack that bread and by my nose. Anything is possible. Yeah.
So we're excited to have Jed Johnson on with us tonight. He's the co-founder and chief technology officer at NanoFiber Solutions. I've been lucky enough to call Jed a friend, and he's honestly one of the smartest people I know. And at the same time, he's extremely funny and witty, which I didn't think would work initially, but it works well for Jed. So Jed, welcome to the show.
Yeah, thank you. And Sharif, you
What's
must
up,
not know
Jed?
very many people, so that's
See, there's the wit.
yeah. Well, thank you guys for having me.
Yeah, thanks. So let's start. What is NanoFiber Solutions? Like, let's start simple. Like, what is it?
NanoFiber Solutions is a company that I co-founded with my business partner Ross K. And it was my last year at Ohio State University, or the Ohio State University, if we want to be snooty about it. And we were originally started making plastic cell culture dishes for brain cancer research. So we started with glioblastoma research and then sort of branched out into stem cells and all using plastic dishes with nanofibers in the bottom. And a nanofiber is a small fiber that mimics the structure within your body. So if you look at your skin, your skin, your tendons, your muscle, it's all made up of fibrous proteins, typically collagens. And we make small fibers out of plastic, or we call them polymers, to mimic that. And when we put it in the bottom of a petri dish, you can do all sorts of research in a plastic dish. So that was the start of NanoFiber Solutions back in 2010. So we're about 14 years old now.
So where have we gone from 2010 now to 2024? Like, what has the evolution been?
Right. So a lot. And we have National Science Foundation and National Institutes of Health to thank for that. And so we've received several $1 million worth of funding to develop some of these technologies and a lot of investors to get us to where we are today. But the idea is really to take what we've learned with cells and fibers and then apply that to medical devices. And one of our first applications was a neurovascular embolization product. And so we were packing blood vessels in your brain that were forming little aneurysms and packing that with our nanofibers. And we sold that company off. And so now we're focused on a couple bigger devices. First one is Atrion Orthopedics, and it's a patch for rotator cuff repair. And then the other application is Phoenix Wound Matrix, and it's a patch or a sheet. It's a much bigger sheet that we use for chronic wounds, acute wounds, really any kind of surface wound.
So before Cuff jumps in,
Ooh.
because I know Cuff has so many questions, but I'm going to say when people hear synthetic and they think of it going in their body, they freak out, which you and I both know it's not a big deal. It actually mimics the body and it grows in. But like, how do you combat that conversation?
Yeah, it's a great question, and we're all tuned to be all natural, and so you're right. When we hear synthetic, we kind of have a knee-jerk reaction, but in this case, we're using compounds that are found in your body. So lactic acid, caproic acid, and glycolic acid. These are all naturally occurring acids inside of your body, but we're using them from man-made materials, and so that it's a man-made plastic, man-made polymer that we use, and the polymers that we use are typically used in sutures that you guys have all used, Vicryl sutures, and so these polymers go into the body. They break down over the course of a couple weeks to a couple months, and the byproduct is lactic acid and caproic acid, and these are naturally removed out of our bodies. So they're very clean, very biocompatible materials that have been used for decades inside of the body, and all we're doing is processing it into really fine, small fibers.
I like it. And I think you're talking about you make the rhodium patch, correct?
Correct, rhodium, and we have a couple other devices coming out very soon.
So that's cool because I like that. That's, you put it in between the tendon and the bone and get it to heal better, right? To heal to the tendon to the bone. So I'm really interested in that product. Very cool.
When we looked at how rotator cuffs were failing, most of us might think it's failing as a mid substance, and there certainly are mid substance tears, but we believe most of those re-tears or those failures are occurring back at the enthesis. And so if we think that is where that failure is occurring, we need to put something that is directly addressing that problem. And so putting something on top of the cuff would help mid substance tears for sure. But if it's not reintegrating back into that bone, that's where we need to focus. And that's really what rhodium does is help that tendon sort of interpenetrate back into the bone. And there's a very specific hierarchy going from bone to tendon. There's 4 zones there. And traditionally, my background is tissue engineering. A tissue engineering background would say, okay, we need to recreate those 4 specific zones and then make a patch that fits into there. In reality, we put a scaffold that allows a in situ repair, or sort of a natural repair that your body is doing. We're just providing the right environment for it.
Now, how long does Atrion stick around, like rhodium stick around between the rotator cuff and that piece of bone?
By 3 months, almost all of it is gone, and and I'd say by 4 months it's completely gone. So in that range, 3 months approximately, and it's not a mechanical bolstering or mechanical strength component. So some people think, we're going to put this patch on there and day 0 it's a lot stronger. Day 0 it's equivalent to standard of care. All we're doing is really putting I call it the bologna on a bologna sandwich. So if you think of your bone and tendon as the pieces of bread, we're putting rhodium right in the middle. So 0 strength improvement at day 0. But what we saw from the sheep studies is that at 6 weeks, we're already about 35% stronger. And by 12 weeks, we're about 75% stronger than the standard of care. So if you look at that trajectory, we're not there today, but we hope that potentially down the road we can even affect physical therapy and rehab procedures by shortening those procedures, getting people back to work or back on the golf course, wherever they want to go, faster. Right now, we're really just focused on improved outcomes, but we'd like to get there and show improved rehab protocols.
Now,
Yeah, I think that's
didn't-
awesome. I think not a lot of people know that, when you get your rotator cuff repaired and it heals, it's just like scar tissue. And if you look at it under a microscope, it's not normal rotator cuff tendon. So this is kind of cool with your wick, and you put it in between to regenerate normal rotator cuff, which there's no other patch that I know on the market right now that can do that.
And we've talked to some groups that specifically have looked at other interpositional scaffolds, and we call it interpositional because it's going in between the bone and tendon. And they said, every patch they tried actually made that repair weaker. And so with Rhodium, we've really focused on improving healing, reducing scar tissue, and when you have something that's relatively avascular, like a rotator cuff tendon, you really need something to bolster that healing process. And we show the same sort of mechanism of action in some of the chronic wounds that we treat with Phoenix Wound Matrix, that we can put this nanofiber scaffold into these wounds that have no measurable pulse. There's no blood supply. These patients are scheduled for amputations, and reestablish that blood flow and save some of these amputations. And it's that same concept that we're putting something in there that kickstarts the healing process and allows it to heal naturally.
Man, that's better than chicken nuggets, bro. That's amazing.
A lot better.
Well, let's ask that question, because usually when you end up doing something really cool, you start messing around with it to see what else you can do with it. So have you guys done anything unique with nanofibers that you'd be like, what?
Yeah, so as Cuff mentioned, they're chicken nuggets. We in case the rotator cuff doesn't work out, we're expanding into chicken nuggets, and
Chicken
we drink a
nuggets
lot
or real chicken? Like real chicken?
real chicken. Yeah,
Oh.
this first sample is from one of my chickens. So we drink a lot of nanofiber Kool-Aid, and we can apply nanofibers to a lot of applications. And one of the applications, it's really tissue engineering, but a very different purpose. So in the cultivated meat space, that's the term that they prefer. Lab-grown meat, fake meat, those don't quite have the same ring as cultivated meat. And so the idea of growing muscle cells on a scaffold, in this case, it's to eat. It's to replace animal slaughtered meat, and so they're growing muscle cells on scaffolds. And from our tissue engineering days, we know cells grow very well on our scaffolds, and that was the impetus behind the medical devices. And so we have applications where now, typically, instead of using polylactic acid based fibers, we're using pea and corn and soy based fibers, but same concept. We spin that into nanofibers, and we're growing muscle cells on there. And our first product was a chicken nugget, and the original muscle cells were from some of my chickens here at my house.
So hold on a second. So you're telling me you can grow a chicken nugget? That's interesting.
Out of your pet.
Out of our pet.
So
Yeah, we can do it.
You eat your
The
pet?
question is,
No, he didn't eat the pet. He made it into a chicken nugget without killing the pet.
right.
Oh,
But we can
that's cool.
we can do it. The question is, can you afford it? And that's the big question.
How expensive is a tissue engineered chicken nugget?
I don't have the number on that. The first hamburger that was made by Mark Post from Belgium, I think it was like $300,000 for that hamburger. Yeah.
I thought you were going to tell me it was like $20 a nugget. I thought you were going to tell me it's $20 a nugget. I'd be like, that's not terrible.
No,
Ferrari or a burger?
And you can fly to Singapore. You can actually order some of the products there in Singapore. So it's coming down. It's not $300,000, but it's not $20 either. It's somewhere in between there.
Wow. Well, so what's on the horizon, Jed? What is NanoFiber Solutions got on the fire? Like, what's happening?
Well, it's really scaling up and scaling out activities. We sort of have this stair-step approach where we take something relatively low risk, low entry, through the FDA, so wound care. It's an external product, and it gets us into that medical device world using a new manufacturing process. We use electrospinning. That's our manufacturing process. We've stepped that up now with Rhodium, the rotator cuff product, and we're building additional rotator cuff products that have some extra bells and whistles on them to add functionality. And then back at the mothership, NanoFiber Solutions, if you will, we have our next candidate would be a vascular graft, and I've personally presented to the FDA twice on this product, and I'm excited about it. It just takes a few more zeros and a few more years of development than the wound care and the rotator cuff product, but putting in vascular grafts for dialysis patients, and so they all need arteriovenous access, and so we can put in a new blood vessel, and same idea. Our scaffold breaks down and regenerates healthy tissue, and then the final product is a soft tissue augmentation mesh, so something like a hernia mesh, and same idea. We can rebuild healthy tissue and eliminate the scar tissue, and to me that really speaks to the healing potential of nanofibers, is that we can put it in for skin, we can put it in at bone tendon interfaces, we can put it in as a interposition vascular graft on the arterial side or the venous side, and we don't get scar tissue, we don't get ectopic bone formation, we get whatever tissue we put it into. So when we put it on skin, we get skin. When we put it on bone tendon interface, we get bone and tendon, and that's the power. We're not pumping it full with growth factors or BMP7 and growing ectopic bone and the ends of our elbows because it's full of BMP. It's facilitating your body's healing.
That's fascinating. I think what you're describing is essentially going to revolutionize how we do a lot of different things in medicine, and you've taken away the concerns that many people have with saying, oh, well, that's synthetic, because I mean, let's be honest, in orthopedics we used a lot of synthetic things in the past that didn't work, but this one is actually being integrated. It's going away. So theoretically, I could get it in my shoulder today, and 4 months from now, it's not even in my body because it's absorbed, which is really cool stuff. So, and you know what? Keep pushing the envelope. The next time we have you on, I want to hear that you guys like nanofibered a car or something like that.
Well, are you guys volunteering your cars or sneakers or anything that we can do?
You could have my Prius.
You have a Prius?
Yeah.
Oh, why is that? Now, tell me you live in California without telling me you live in California. Jed, you're awesome.
I'm Bill Gates. Later.
Jed, you're awesome, man. Thanks for coming on, and good luck with everything you guys are doing over at Atreon and with Rhodium and with whatever else is coming in the future, and of course the chicken nuggets. So until next time, thanks for coming on, my friend.
Yeah,
thanks,
appreciate you both.
Right.
Thank you for the questions.
See you, Jed. Thanks.
Trying to get a lot of dough. Anything is possible. Turn me up in the headphone. Yeah. Trying to get a lot of dough and dirt through all the obstacles, cause anything is possible. Yeah. Oh man, I got a lot of gold. Stack that bread and by my nose. Anything is possible. Yeah.